Hello and welcome back. Okay, so the build hasn't changed at all since my prime numbers demo, but I've been doing quite a lot of planning and design work on the side. Now what I'd like to do today is take a look at this section. Now the overall build when it's complete, I expect to have the register stack on the left, but with the memory bridge and the main memory underneath it. The pipeline and the ALU I think can probably go one above the other once we've converted it to PCBs, and probably the clock can go in the same section, and then the peripherals will be over on the right here. So what I'd like to do when it's all done is have one big backplane that connects it all together, but things are getting pretty tricky. The kind of mess of strip board and little segments of board behind here are starting to cause me problems. So I want to design a single backplane for the registers and memory. So that's most of the things that hang off the main buses. And that will neaten all of this up. And if I bring all the wires out for interconnection on the side, that will make things nice and neat for moving on. So I'll probably put this together in 3 segments and then merge it all up at the end. Okay, I actually need to disassemble this thing now. Now, I don't know if I'm going to add any functionality to the constant register, but I'm almost certainly going to remove the main bus display from here. So there's going to be one more iteration of this. The bus control I'm also going to do another version of. I've had a couple of mistakes. I had to bodge wire on here, and there's a couple of additions I think would be worthwhile. Looking back on the PCB for this, there's actually like a complicated loop of ground which doesn't help at all with trying to keep clean signals, and a better hand routing of this would probably be quite a big benefit. Now these little mini PCBs I made to make the interconnections neater, they were a good idea, but in hindsight it would have probably been better to switch straight to a large backplane PCB. Once again, the strip board, that's served me quite well, but after multiple changes this got pretty messy, and I think there's probably some high resistance interconnections between here with all the mess that aren't doing me any favours. So let's design a better PCB. Okay, I'm starting with the connectors imported from the transfer register because there's a lot of similar ones that we're going to need, and it's easier to do it this way. The address bus and the transfer bus goes through the 5 counter address registers and the transfer register. So I'm just going to need 6 of those. But for that whole left hand side, I'm also going to need power connectors. And then on the right hand side, everything is going to need the main bus. So that's 4 GPRs, constant register and the transfer register. I've always found it weird the way the outline in Easy EDA has that weird corner on it. Might seem a little bit silly putting all the labels on these carefully because they're going to be covered up by the module PCBs. Okay, I actually guessed the width of that correctly. That's almost worrying. Right, I need 6 more power connectors for the 8-bit devices. Now we just need 4 of these for the general purpose registers, but we're going to want outputs for these as well, so let's put those in. We can bring the outputs to connect to the breadboards out a little bit neater. I'm not sure where the best place to put the outputs are. We've got the transfer register along here, which we haven't put in yet, but then also going to have memory down the bottom, and I think I need to try and guess the connections for that, or this backplane's not going to last very long. Now let's see if we can guess at what memory is going to be. Make it the same width. Have a number of chips in memory is going to be quite low, but I do want to have some extra control circuitry in there and be able to have a ZIF socket and stuff like that, so I do want a bit more space. I'm not sure if I need quite double one of these registers though. I need an address header for that, and I also need a separate address header for connecting to the address bus before memory is in there, because we know from experience that we can't connect to the pin header points very well. Okay, so something I've done is I've loaded up the bus control, deleted all the components and saved it off as a module, which should give me copies of all of those connections. One thing I have noticed is some of these broadcast lines are connected together on the bus control side, but the nets have the same name, so they're going to get connected together independently on the backplane, and I don't want that to happen. That's all the connections for bus control and all the registers. Okay, so this is the input control to the memory board, which we haven't created yet. we know we wanted those 4 lines which come from bus control, but we also want the clock and the reset as it comes into the main system. Okay, I've had a small rethink here. Now, it was my plan to put the memory bridge and main memory all on one PCB, but I think I might be better off splitting it in 2 to put the memory bridge over here and main memory on its own board. I'm looking at this predominantly because of the troubleshooting I've been doing over on the CPU side of things, which should give you an idea of roughly when I was doing this. Okay, so I'm going to need a mem data connection between them, and then I need the lines relevant for the memory bridge to come in to this new board that's going to sit here. Okay, so those are pretty much the lines we need anyway. Still want another copy of this. Going to need an additional power connector to go to the memory board. And I do need some additional main bus outputs for connecting devices to. I'm going to stick a couple in side by side at the top and bottom because I want to avoid having chained off main bus connections, because I don't think they're doing us much favours. Now these load and assert lines that we brought out before, I'd like to do something different with these. If I create a dedicated device header, give it 5 volts ground and the relevant load and assert lines, then this backplane board becomes a little bit of a hub for power and ground, which is going to make it a bit easier to be confident that they're coming from the same location. I've just tied what would be the load line for the ALU to ground, just so we can keep the same pin layout. I think the layout of this is shaping up. But something I would like to do is have a bit more of a think about power. So if we're effectively distributing power out of this board, then we want to have a robust way of getting power in, and then we want to add a few additional power out lines. Well, 6 of those should be more than enough. Okay, we're not going to be connecting data lines. I'm assuming 5 and 6 are tabs, so we might actually want to ground those. I'm not sure if that's the right thing to do though. But that's good for 2 amps, which should be enough for what we're going to be doing. Here's the big deal though. I think what I want to do is add room for a whole bunch of capacitors on here. Now, all of these PCBs will have their own decoupling, but I don't think anyone's going to tell me I've got too much. Okay, let's see if we can get some capacitors on here. Okay, I'm not specifically choosing this rating, although that wouldn't be terrible, but I was predominantly looking for one with the right lead spacing. So I want some larger electrolytics and then some 0805s. I want room for a pair of caps by every board and its power inputs. Well, I think that is a workable board. I want to spend a little bit more time on the routing, particularly for these signal lines. But I think if I hand route those and then get the auto route to just put all these vertical bus lines in, it should be good. Okay, this package took ages to come. I'm really quite excited to have a look. This is looking good. Okay. This should be quite a nice improvement. I'm going to go and collect some components and get the soldering iron set up. Back in a moment. Okay, I stuck locations for 2 SMD capacitors by every board. This is mostly me just trying to create some bulk isolation between the modules, so I don't think there's any hard and fast rules for what values of capacitors belong there. These are 47 microfarad. These are probably much higher than I need. Okay, these ones are 1 UF, so they should be dealing with slightly smaller spikes. Find some pin headers, I think is the next shortest thing. Okay, time for lots of pin headers. Turns out you can connect them all up like that. Right, I'm going to leave those 4 pins because I'm more likely to get a shorter segment later. Okay, you're not going to believe this, but I actually had exactly the right number of turned pins. I thought I was going to have to go to my tub where I know I've got a few spares, but no, not necessary. Obviously, I've only tacked all of these in. I need to go over and solder the back, but for now, I need to go and find the appropriate pin headers for these. Okay, so all of these connectors on the outside, I want to have the more DuPont style ones. I can't put DuPont cables into these turn pins. So these are 680 microfarad. Now with this board having the main power in and then distributing power to all the other sections, I wanted to get a bit of bulk power balancing here so we can be pretty sure the voltage won't ripple around too much. Or at least that's the goal. I fully expect people who know this stuff better than me to come back and tell me I've done the wrong thing. Okay, so that's all the components on. All I need to do is go through and actually finish off all the solder joins. So all of these big long strips I've just tacked on the ends. So that's going to take a little while. I'm going to clear all my components out of the way to make some space on the desk first. Okay, so I've just got a big stack of soldering to do to actually finalise all these connections. I have to say this is a lot better than doing the equivalent soldering work on the strip board. On the strip board you don't really have solder mask, which is this green stuff, which is designed to repel the solder. So it's a lot easier to create a bridge between two adjacent connections. And the holes on the strip board are just holes in the fiberglass, whereas these are plated through holes. So they just kind of suck the solder in. So even without a nice dome, you can be pretty sure you've got a really good connection. So all the 8-bit bus connections to the registers. This is the DuPont output for mem data. Right, that's all the 8-bit buses done. Right, so that's all the 16-bit buses done. It's just all these extra interconnects down the side. These are the LHS and RHS outputs that go to the ALU. Kind of wish I knew exactly where I was physically going to place the ALU relative to these. I'm basically guaranteed to either end up with cables that are too long or too short. Well, I think that's all the soldering done. I'm going to clean up the PCB and then we can run a few checks. Okay, well I've given this a bit of a clean up and inspect. I did find a few joints down here which I'd missed. Now, big advantage is I've got a power connector now. If we've got power and ground well, that gives us an excellent start. So that's showing exactly 506 everywhere. Probably this middle one is going to be the toughest to do. Okay, that was actually easier than I thought. Okay, actually seeing some of the LEDs light up there. Possibly got slightly more capacitance than I need. Oh, look at that. I've never been able to pick a sizable chunk of the build up like this before. Okay, well, that's not going to be stable without the inputs, but looks like everything is doing what I'd expect. I'm going to have to make up a few extra custom wires to plug this back into the breadboard section, and I think I'm going to leave that where it is today because that's another big chunk of work and I've already got an awful lot of footage to edit together for this video. But this is a nice bit of progress. Well, I know I didn't move the design or any of the underlying systems forward today, but this is a nice bit of infrastructure move towards a completed circuit. These circuits for the memory bridge and the main memory are what's up next. But what I really want to do is start on the circuits here for the ALU and the pipeline, which is mostly going to be translating what I've got on breadboards. But thinking about it, I want the ALU and breadboard to fit here, and I need to know how wide that's going to be because I want to keep things looking fairly neat. So I'm going to need to rough out all of them before I can really finalize any of them, and that's going to take a little bit of time. But I'll try and find some other stuff to get on with in the meantime. Okay, hope you found it interesting. Thanks for watching. Goodbye.